Okay, this is going to be about discrete random variables. Discrete meaning that it's not continuous, so you're not dealing with something like amount of water that you'd pour into a cup, because that would end up being measured in like kind of on a whole spectrum, but rather that you're dealing with something that is like you can count individual pieces of it. So like the number of dice rolls, the number of people. It's going to be some sort of whole number. If you were to put it on a number line, it would be like dots on a number line as opposed to filling up the whole number line. Random, just a result of a random process. Variables, meaning that x could be any value. So the way that we tend to write these is the probability of, and then this capital X is equal to this lowercase x. And when I write these, I tend to do straight lines for the capital X and swoopy lines for the lowercase x. This capital X is the discrete random variable. And the reason that we write this notation like this is so that we can say, what if x was equal to a specific thing? Let me get into this example, and that might help. So we're going to say that our random variable is the sum, so adding up, of a fair 4-sided die and a fair 6-sided die. So over here I wrote out like 1, 2, 3, 4 is what I could get from a fair 4-sided die, and then 1 through 6 on a 6-sided die. So obviously like this right here would be the result of getting a 2 on my 4-sided die and a 4 on my 6-sided die. So I could get a 6. So the smallest sum that I could get is a 2. The largest is a 10. And then the sample space refers to what are all of the possible outcomes. And it's not talking about probability at this point. Sample space just means what could happen. And I could get a 2, a 3, a 4, a 5, a 6, a 7, an 8, a 9, or a 10. I can't get an 11. I can't get a 1. I can't get a 6.5. So these are my only options. Notice that this sample space exactly populates the top row of this chart. Okay, so this chart is like, what are the possible outcomes? Boom, sample space. And then down here, what we have is the probability that my variable takes on that value. So the probability that I get a 2 is 1 out of 24. Everything's out of 24 here because there are 4 by 6, 24 outcomes. And so the probability, since there's only 1 2, is 1 out of 24. For sure, you are welcome to simplify this. Like you could write this as 1 out of 12 if you wanted to. I just left it as 24 so that we could add stuff up a little bit easier. So now that we've got a scenario, let's look at what this notation really looks like. If I wanted to find, for example, just straight up the probability that my random variable takes on the value of 7, well, that's just going to be 4 out of 24. So I can just answer 4 out of 24. Careful here, sometimes people freak out because there's too many equal signs and I don't know. But like all that it's saying is that the probability that my variable is 7 is 4 out of 24. Part of the reason that we have this notation is so we could also do things with like inequalities. So if I said, what's the probability that it is less than or equal to 4? Well, then you can say, oh, well, then it could be a 4 or a 3 or a 2. So in that case, I'd have to add up 1, 2, 3, 6 out of 24 would be my answer here. And then we can also do things like, what is the probability that my variable is equal to 3 given that I know that it is less than 4? Okay, so this would be a scenario where like you're playing a game with your friend and you go up, you like go get a snack and your friend is like, yes, I got less than 4. And you're like, oh, I really wanted them to get a 3. So what you know is it's less than 4. So it's either a 2 or a 3. But in this case, you want to know if the probability is a 3. So what you would do is say the denominator is 1/24 plus 2/24. And the numerator would be the probability that it's a 3. So down here, you've got all of the probabilities that it is less than 4. And here it is that it is actually a 3. Once you work this out, you'd get a 3 out of 24 out of here. It would end up being equals 2 out of 3. So big ideas. It needs all of these down here have to sum to 1 because that has to take into all of the possibilities. And then after that, it's just kind of interpreting the notation that you've got here. So let's go through a quick example. We did this in class, but if you missed class, here you go. So we've got a distribution of a discrete random variable x. The possible outcomes are 1, 2, 3, 4, and 5. And they've just given us letters. Shoot. Well, what we know is that all of these right here, have to sum to 1. So I'm just going to write that out. Voila. P plus Q plus 2P plus 2Q plus Q minus P equals 1. Then we should be able to simplify. Work that out. You get 2P plus 4Q is equal to 1, which is not enough because we got 2 variables here. So then we need to look at what else it tells us. And it says that given that the probability that my variable is less than 3 happens to be 3/10. So we're like, okay, the probability of getting a 1 or a 2 is is 3/10. So we could write out then, okay, P plus Q equal to 3/10. That's not 3/10, that's 3/10. There we go. And then, boom, you have a system of equations. Go ahead and solve whichever way you prefer. You could solve for P and then replace it, or you could multiply something. Feel free to pause and make sense out of this. I just multiplied here by -2, added the equations together, got Q as 2/10, and then plugged that back into this original purple equation and got P as 1/10. Okay, so then you can actually get the probabilities up here. And then voila, you can answer the final question, which is find the value of P, the probability that our variable is equal to 5, which is just 1/10. Le voila. The final thing that we talked about, at least with fourth hour, I forgot this for you, but we'll go over it on Friday, is expected value. And this is the mean score if the experiment were repeated multiple times. So if you rolled the die many times, what would you expect the average result to end up being? And the way that you calculate this is capital E of capital X, and this is written as mu most of the time, which has got this long swoopy bit right here. And it is just the sum of the value of your X times its probability. So let's say you've got a die that has its 6 sides, and you've got a 1, 1, 1, 1, 1, and a 10 on it, right? So obviously the most likely outcome is a 1, but every once in a while you could get a 10. So the way that I would figure this out is I would first of all probably want to say okay, my sample space is 1 and 10, because those are the only 2 outcomes that I could possibly get. The probability that my variable ends up being a 1 is 5 out of 6, and the probability that my variable ends up being a 10 is 1 out of 6. So then my expected value here would be the sum of if I take each of the individual X values and multiply them by their probabilities. So in this case, I would take 1 and multiply that by 5, 6, plus 10 and multiply that by 1/6. So in this case, you would get 2.5. Let me know if you have any questions.